All right, so in the last segment, I made this sentence and I said that this was similar to a text file. And I have the sentence, the quick brown fox jumped over the lazy dog. And what I wanted to make a point of is that the word, uh, the, the sequence of characters I have here, there's absolutely nothing, there's absolutely nothing in here that would allow me to say, change the font of these characters or to make them a different color or any sort of layout like that is just not present in a text file. And there are applications on your computer that are meant to do nothing but edit text files. So on a Windows computer, you would have Notepad. On a Mac, you would have Text Edit. And later on in these video chapters, I'll have you install another program called Visual Studio Code that's really, really, really good at editing text files for things like editing HTML and CSS. Um, I have a memory of explaining this to a student of mine at one point, and I mentioned, well, you have Notepad on your computer, don't you? And my student at that time said, oh, that thing. I don't like that thing. It's worthless. I said, well, what do you mean? And he said, well, it doesn't have spell check. It doesn't let me change the color of the text. It doesn't do this. It doesn't do that. And to that, I would say, well, that's the point. A text editor is not Microsoft Word. It's not Google Docs. It's not meant for an average person to create a document. It's meant for a future programmer like yourself to edit code. That's what it's for. So now I want to address the question that I promised I would address. Is how does a computer system take a character or a sequence of characters and somehow get them to stick onto a hard disk? How is data stored on one of these hard disks? So I'm going to get rid of my sentence here. And I'm going to ask you to engage your imagination, all right? I want you to imagine that you have been tasked with the job of building a computer, but you're in luck because you live in an alternate universe. And in this alternate universe, there are only two numbers, 0 and 1. So if you're a computer engineer that lives in the universe where there's only 0 and 1, you're in luck because your computer could be very, 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 very simple. There you go. You're done. I made it. This is my computer. It represents 0 just by being like this, off, and it represents 1 by being on. That's it. I'm done. My work here is done, folks. But alas, that's not real, right? We have to at least be able to represent the number 2. So now I need to figure out how I'm going to do that. I'm stuck. I mean, I could invent a new kind of switch. But let's think for a minute. Electronics, by their very nature, deal really well with off and on, right? You turn your TV set off and on. You turn your microwave off and on. You turn your alarm clock off and on. You don't turn them halfway on or halfway off. So how am I going to represent 3 digits, right? How am I going to represent 3 digits with this thing? It's only really suited to represent 2 digits, 0 and 1. Well, it might help if you knew that you had a whole warehouse full of these, right? You've got a whole bunch of these. So while we're waiting for the development team to come up with some crazy new invention that can represent 0, 1, and 2, we're just going to run out to the warehouse and we're going to get another switch. There we go. Now, with this, I can represent the number 2 quite handily. I can start by representing 0, and then this will be 1, and then if I want to do 2, I'll come over here, and get this. If I want to represent the number 3, I can go like this and put them both on. Now that's really, really hard. That's going to be really hard for me to remember. So yeah, I'm going to get some sticky notes to help me remember what's what. Okay, so here we go. I'm going to say that this represents the number 1, and this represents the number 2. All right, very nice, very nice. Okay, there we go. Ready? So this, like in its current state, this represents 0 because all the switches are off. This represents 1. This represents 2, and wait for it, this represents 3 because 1 plus 2 equals 3. So now I can represent 4 digits with 2 switches. Pretty cool. But what if I want to represent the number 4? Well, remember, I've got a whole warehouse full of these. So here you go. Great. Now I have 1, 2, 3 switches. All right, everybody see that? 1, 2, and 3 switches. I got 3 switches, and I'm going to represent the number. I'm going to go up to the number 4. Ready? Here we go. We'll start with 1, 2, 3, because 1 plus 2 is 3, and I'll turn these off. 4. So what do you think? Can I represent the number 5? Of course I can, because 4 plus 1 is 5. Can I represent the number 6? Of course I can, because 4 plus 2 is 6. Can I represent the number 7? All right, here we go. 1 plus 2 plus 4 equals 7. So with 3 switches, I can represent up to 8 digits. That would be 0, 1, 2, 3, 4, 5, 6, and 7. Now, on the next slide, I'm going to show you how that relates to our problem of how do we take characters and get them to go onto our hard disk.